Logarithms, solving using logarithms. We're going to solve the equations below. We're going to round our answers to the nearest hundredth. 7 to the x is equal to 86. So we're going to need to convert to a logarithm. On all of these, we're going to. So we have log base 7 of 86 is equal to x. So we're going to need a calculator. I'm going to go to my Desmos graphing calculator here. And on the graphing calculator, if you hit the keyboard here and functions, then let's see, it needs to be bigger for a minute. Under miscellaneous is the log base A. And once I have that there, now I can get rid of the keyboard and I can make it smaller. So we have log base 7 of 86. And there you can see our answer is 2.28. So we have x is approximately equal to 2.29. 2.29. So that means if we put 2.29 in here, it would come out to be something close to 86. So we make sure to say this is an estimate here. And this is the hundredths place right here. This is the hundredths place. So it's tenths, hundredths, hundredths. The 8 is the hundredths. The 9 is the thousandths. All right. 16 to the n is equal to 87. So we have, we're going to rewrite this. Log base 16 of 87 is equal to n. So I'm just going to go in here. I'm going to just change this to 16 of 87. And whoops, I'll get 1.61. So 1.61 is approximately equal to n. And this one, log base 3 of 65. And, just to be clear about something, we can obviously just switch this and make b over here. It doesn't make any difference. Notice that I use an equal sign here because this is an exact value for b. This is a number, so b is equal to that number. We don't know what that number is. It's probably kind of hard for us to figure out until we put it into the calculator here. And then we can see that that number is approximately, so B is approximately 3.799. So that's going to be approximately 3.80. So when we round to the nearest hundredth, this is going to go to a 0, that's up, which means we need to round the 7 up to an 8, and then this 9 up to a 0. Last of these simpler ones here, log base 6 of 61 is equal to m. Put it down there. Log base 6, whoops, thought that might happen the way I highlighted there. It looked a little weird. Log base 6 of 61 is equal to m. So that's going to be, m is approximately 2.29. All right, let's see. Now to these slightly more difficult one here. So before we deal with the base and the exponent, we have to get rid of this 2 from that side. And since we're multiplying here, the inverse of that is dividing. We divide by 2. So we get 11 to the n minus 6 is equal to 25. Now, our exponent, this is still all one exponent. So when we convert here, we have log base 11 of 25 is equal to n minus 6. Now, I'm going to add 6 to both sides. And the way that I'm going to do this is I want to show you an exact answer here. log base 11 of 25, and I'm putting it in parentheses here so we can see that we're not going to combine the 25 and the 6. So this is a number. We're adding 6 to that number. So this is a number. We're adding 6 to it. And that equals n, and that's an exact answer. So now here in our calculator, whoa, sorry about that. There you go. Here in our calculator, we're going to do log base 11 of 25. And then we can take that and we can just add 6 to the whole thing. That's going to be 7.34 about. So here we have 7.34 is approximately equal to n. On this one, again, here we're multiplying by -4, so we're going to need to divide by -4. -82 divided by 4, well, let's see. 82 divided by 4 is 20.5. All right, so when we divide, we have 3 to the x plus 9 is equal to 20.5. The negative divided by negative makes a positive. Now we're going to convert to a logarithm. So we have log base 3 of 20.5 is equal to x plus 9. So again, notice that this whole exponent comes over here. All right? And now to isolate, we're going to need to subtract 9 from both sides. When we do that, we have log base 3 of 20.5 minus 9 is equal to x. So in our calculator, we're going to make it a base 3 of 20.5 minus 9. And we'll get that x is approximately equal to negative 6.25. And that is the solving using logarithms. And out.